Welcome to the session on representations of data, outliers. The objectives for this session are to identify outliers in data sets. An extreme value that lies outside the overall pattern of the data is called an outlier. So, for example, if we consider this scatter diagram, we can see that the majority of points follow a particular pattern. However, there is one point that's not quite following the same pattern. This is called the outlier. There are two main ways of defining an outlier. We're going to concentrate on them one at a time. The common definition of outlier is firstly, any value greater than Q3 plus k times Q3 minus Q1 for a value of k greater than 0, which will be given. Now, this expression may look a little bit complicated. However, a diagram will hopefully explain what it's all about. So let's take a look at this, what we might call a number line. We've got the minimum, we've got Q1, the lower quartile, we've got Q2, the median, we've got Q3, the upper quartile, and we have the maximum. Now the expression Q3 plus k times Q3 minus Q1 lies somewhere between Q3 and the maximum. Outliers will lie in the region between this value and the maximum. And similarly, at the lower end, a common definition of outlier is any value which is less than Q1 minus k times Q3 minus Q1 for a value of k greater than 0, which will be given. Again, this value lies somewhere between the minimum and Q1. And an outlier will lie in the region between this critical value and the minimum. Now let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 2a first. The heights of children in a class have lower quartile Q1 equals 149 centimeters and upper quartile Q3 equals 155 centimeters. An outlier is an observation that either falls 1.75 times the interquartile range above the upper quartile, or 1.75 times the interquartile range below the lower quartile. Work out whether 200 centimeters is an outlier. Now clearly 200 centimeters is greater than Q3, which is 155 centimeters. So we're looking at the top end. So when solving this, we need to find the value of Q3 plus 1.75, which is the value of k in our example, times Q3 minus Q1, which is equal to, and now we're just inputting the values into this expression, 155 for Q3 and 1.75 for k and 149 for Q1. And tidying up gives us that this expression is equal to 165.5. Now 200 is greater than 165.5. Therefore, 200 centimeters is an outlier. And now for part B. We are required to work out whether 160 centimeters is an outlier. Let's solve this. We know that Q3 plus 1.75 times Q3 minus Q1 is 165.5 from part A. That's the top end of the critical value. And we can also find the lower critical value, which is Q1 minus 1.75 times Q3 minus Q1. So inputting all the values as shown, here we've got Q1, which is 149 centimeters. Here we have K, which is 1.75. And here we have Q3, which is 155 centimeters. And tidying up and inputting in our calculator will give us that this critical value is equal to 138.5. So here's a summary of the key information. Since 160 is between these key points, we can therefore safely conclude that 160 centimeters is not an outlier. And now for part C. We are required to work out whether 138 centimeters is an outlier. So let's solve this. We know that the lower critical value is 138.5 from part B. And therefore, since we have that 138 is less than 138.5, we can safely conclude that 138 centimeters is an outlier. So here's a summary of the key points. Using K equal to 1.75, we've concluded that 200 centimeters in this example is an outlier, 160 centimeters is not an outlier, and 138 centimeters is an outlier. Now, this is the case for K equal to 1.75, but what if we used a different value for K? Say K is equal to 2. Let's try this in our next example. So, let's ask ourselves, is 200 centimeters an outlier? Again, let's input the values into our expression, this time replacing K by 2. And plugging in all the values as before gives us that this expression, or the upper critical value, is 167. Now 200 is greater than 167. Therefore, 200 centimeters is an outlier. And now let's ask ourselves whether 160 centimeters is an outlier. We know that the upper critical value is 167 from 3 part A, and the lower critical value is Q1 minus 2 times Q3 minus Q1 with all the values of Q1 and Q3 input, as shown, to give us 137. Now clearly, 160 lies between these two critical values, so therefore 160 centimeters is not an outlier. And now for part C. Work out whether 138 centimeters is an outlier. So let's solve this. We have 167 as the upper critical value from part A, and 137 the lower critical value from part B. And therefore, since 138 is in between these two values, we can conclude that 138 centimeters is not an outlier. Let's now compare our results. Has anything changed by changing the value of K? When K is equal to 1.75, 200 centimeters is an outlier, And when k is equal to 2, 200 centimeters is still an outlier. 160 centimeters is not an outlier in both these cases. However, 138 centimeters is an outlier when k is equal to 1.75, but is not an outlier when k is equal to 2. So something may change if the value of k changes. This brings us to the end of this session. If you have understood its contents, you should be able to identify outliers in datasets. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.